mode.
Good morning everybody, and welcome to this new webinar from VELP Laboratories. Today, we are going to talk about solvent extraction, and in particular, we will see how to overcome analytical challenges for the extraction of fats, oils, and pollutants. Before starting, let me introduce myself. I'm Mattia Mura, Marketing and Communication Specialist, and today with me there is Vittorio Laghezza, Application Specialist from our Analytical Department. Before starting, let's see in brief the agenda. We will start with an introduction to solvent extraction, in which we will see method of the analysis and range of application. Then I will leave the word to Vittorio, and with him we will start with the direct extraction. In particular, we will see the analytical challenges and application and results. Then we will switch to total fat determination. Also in this case, we will see analytical challenges, application and results. And then we will close this session with a Q&A session, in which we will try to answer to the most of the questions that we will receive. And at the end, of course, we will answer to the question by email to the ones we didn't have time to answer to. So please use the chat box you have on the right of your screen and write down on the question that will arise. So let's start with an introduction to the solvent extraction. So solvent extraction, as you may know, it's a widely used method for the separation of mixtures based on the difference in the solubility of the components that we have in our samples. Solid liquid extraction in particular, we refer to the process where the soluble components are removed from a solid using a liquid solvent. The solvent method is a well-recognized and approved method, and it is approved by the most important worldwide organization and regulatory bodies, including AOSC, UNI, EAP, and so on. In particular, when we refer to solvent extraction, we can have two different types of analysis. In particular, we can talk about quantitative analysis or quantitative determination, where the total amount of the extracted matter is measured gravimetrically. This means that we are determining how much of a specific component, such as, for example, a fat, is present in the sample. Then on the other side, we have the qualitative extraction or qualitative analysis, in which the extracted matter is further analyzed to identify different types of components of this extract. So in this case, the extraction is a sample preparation for this analysis, and this analysis will allow the laboratory to gain deeper insights into the composition of the sample beyond just the total content. In this case, when we talk about solvent extraction, we can cover a wide range of application, and we can analyze a wide range of different matrices. In this case, we can start with food, feed, and beverage. In this case, the labeling side is very important. Indeed, we will, with Vittorio, we will, for example, extract fat in order to determine the fat content in a food sample in order for labeling purposes. Of course, also in this case, the quality control, quality assurance, or the research and development purposes by enabling the creation of different type of formulation or improving the nutritional profile is very important. On the other side, also the environmental and agricultural field is very important when we talk about solvent extraction. For example, for monitoring pollution and protecting human health. In this case, the extraction process, for example, of oil and grease in water and wastewater is important, as well as the extraction of pollutants such as PCBs, pH, pesticides, dioxins, and so on for samples like soil and sediments. Then, lastly, the chemical and petrochemical industry. In this case, solvent extraction is important, for example, in those industries such as plastics, textiles, pulp and paper, and so on. Also, in this case, in most of the cases for quality control, quality assurance, and in particular for the separation and purification of different compounds, ensuring that our final products meet the specification required. So thank you for the attention. I leave the stage to Vittorio, and with him, we will go through the analytical challenges of the direct extraction and the total fat extraction.
Hello, everybody. I'm Vittorio Laghezza, and I am application specialist here in the VELP laboratories. Today, we will focus on both the direct extraction and the total fat extraction in order to go much more in depth in each analytical challenges that we can face during both the process. Starting from from some general things that we can face in both the extraction, we have that for solid sample is really important, the sample preparation, because we have to cut and grind them before to start the extraction in order to decrease the particle size and increase the surface available for the extraction. It's really important to have an homogeneous aliquot of the sample before analyzing it into our solvent extraction in order to have a representative aliquot of our sample. It's also really important to store the sample correctly, because we have that, for example, in the food and feed sector, we can have the degradation process of the sample before starting the analysis. So it's really important to store it in the proper way. And also another important parameter that we have to take under control before starting the extraction is the moisture content of the sample, because if we weight a sample with an high moisture content, we will weight also the moisture contained inside of the sample. So we have to dry before starting the extraction, and then we can start all the processes into our instrument. So the key point to increase the accuracy is to follow these 3 steps before starting the analysis. Another important thing to take under control is the weight of the sample, because we have that if we want to extract something from a sample, we have to weight a representative aliquot and also an aliquot that can make possible the weighing of the extracted matter from our sample. So it's really important to choose the correct weight of the sample before starting the measurement. And also we have that due to the gravimetric nature for the direct measurement, we have to dry in a really accurate way the extraction cap before starting the analysis, putting the extraction cap without the thimble into the oven for 1 hour, 1 hour and a half at 105 degrees centigrade in order to dry the extraction cap before. Then, after the drying and the transferring inside of a desiccator, we can weight the extraction cap when it is cooled. After the cooling process, we can take the weight in an accurate way on a 4-digit balance or 3-digit balance, and then we can transfer the extraction cap into the instrument. As I have told you before, it's really important also the weighing of the sample before, because we have to weight the sample into our extraction thimbles. And the weighing process is really important, because if we want to increase the accuracy and reproducibility of our process, we have to weight both the sample and the extraction cap in a reliable way. We offer different accessories for our solvent extraction. We have two types of thimbles, the cellulose one and the glass fiber thimbles, that can be used for two different analyses. The first one can be used for quantitative analysis, so the analysis in which we extract the fat from our matrix and we quantify the fat on a balance. On the other side, we have that the glass fiber thimbles can be used for the qualitative analysis. As Mattia told you before, this analysis is different because it involves further techniques after the extraction. So this analysis is just a preparation for the further analysis. And also, in addition, we offer three different shapes of extraction cap. We have the standard one, the large one, and the small one. We offer these three sides of extraction cap to match three different volumes of solvent to be extracted, and also the different shapes of the sample that can be extracted into the solvent. In addition, we have also three different kinds of gasket, because we have to match the chemical compatibility of the gasket that are placed into the instrument with the solvent that is used for the extraction. We have the gray one, the butyl one, that can be used for certain solvent with mild chemical aggressiveness. And we have the Viton one, the green one. Both these two gaskets are provided with the instrument, and the Viton one can be used for when higher chemical resistance is required, and it is ideal for more aggressive solvents. In addition, we have also the Waflon one. This gasket is one gasket that can be used with the broadest chemical compatibility and durability with the majority of the samples of the solvent that can be used for the solvent extraction. Now we can see how we can optimize the process of the extraction of this for the direct determination. We have, as I told you before, that this extraction is has a gravimetrical nature. So it's really important to weight the empty extraction cap before the extraction in a reliable way. So we have to dry the extraction cap at 105 degrees centigrade for at least 1 hour. Then we take out the extraction cap from the oven. We can put inside of a desiccator and let them cool inside of a desiccator with a controlled moisture ambient. Then we can take the mass of this of the extraction cap and note it as hem-tear. It's really important to guarantee the accuracy of the analysis to take this weight in a reliable way. And then we have that we can also optimize the solvent. Choosing the appropriate solvent is crucial to have an efficient and accurate fat extraction. We have that the majority of the official norms states the solvent to be used, but for some R&D purpose analysis or not typical analysis that are regulated with some official method, the choices of the solvent and the optimization of the solvent for the matrix is really important, because we have that the chemical behavior, the chemical compatibility between the matrix and the solvent has to be ensured. We have also the boiling stones that can be used for the high boiling solvents that helps to break the surface tension of the solvent and to make smaller bubbles compared to the solvent that we are using. We have then that in the SIR 158 that the automatization helps the process and helps also the analyst that is performing the extraction analysis, because we have that with this instrument, there is the automatical recognition of the end of the analysis. So when the analysis is ended, the lift rise up and the extraction is ended. So it's really important to have a reliable extraction without burning the matter that we have extracted. And with the automatization, we are also ensuring the safety of the final operator. Additionally, we have that the SIR 158 fully recovers the solvent for the quantitative analysis. So it's really important because we have that up to 90% of the solvent can be automatically recovered and reused for further extraction. So this is really important also from the economical and also environmental aspect, because we are saving money and both also solvent. And also from the safety of the operator purpose, we have that with the Solvent Express dispensing technology, we can also allow safe and precise loading of the solvent directly inside of the instrument. So we have just to quantify the volume that we want to insert with this tool, and we can forward the solvent in each extraction cup in an automatical and low exposure way. Despite these built-in safety features, it is still recommended to operate with the solvent extraction under a fume hood, especially when the operator has to work with volatile or hazardous solvent, in order to ensure the maximum protection of the final operator. Now we can go much more in depth with some application and some result of the direct extraction. The direct extraction can be applied in different sectors, as we have seen with Mattia before, from the food and feed beverage from the food, feed and beverage sector, where we can apply the crude fat determination, to the environmental and agro sector, in which we can both extract with the direct extraction for the quantitative or the qualitative analysis, and also with the chemical and petrochemical sector, in which we can perform this analysis both for quantitative or qualitative purpose. Now we can see some result applied in the animal feed sector, and we have that this crude fat determination refers to a total mixture of fat soluble material that is contained inside of the food and feed matrix. We have that traditionally the crude fat content is determined with methods that involve the extraction with organic solvent, followed by the drying of the extract, and then, as I told you before, with the gravimetric balance, we can weight the extracted matter in order to refer with the percentage of the fat contained inside of the matrix. Now we can see in this table that we have some results that we have collected in our analysis. We have that this analysis was performed in accordance with ISO 11085 of 2015, and we have that we have extracted two different matrices, a feed for chicken and a horse beans. As you can see, we have that the extracted matter for both the matrix is really reliable. We have a low standard deviation with both the sample matrix, and we have that for both the extraction has taken place in a good and reliable way. Now we can move further with the total fat determination, because we have that for certain specific product, the official standard requires the determination of the total fat instead of the crude fat. For this product, it is necessary to use to perform a preliminary hydrolysis step with our HU6 unit. With this unit, we can perform the hydrolysis, and then we can move further into the extractor to perform the total fat determination. This is because some lipids are chemically bonded to other components, such as proteins, carbohydrates, and cannot be fully extracted and determined with the direct extraction. So we need a preliminary step in which we can break this bond, and then we can extract into our unit. We have that several AOSC official method requires this hydrolytic process before the extraction, and after the extraction, we will quantify the extracted matter in the same way of the direct extraction. So we have that the total fat determination is composed by these two steps. The first one with this instrument, that is the HU6, that involves the hydrolysis of the sample using hydrochloric acid for normal, followed by a filtration, because we have to put the sample inside of the test tube with the acid in order to make the digestion happen, and then we can filtrate the sample through this crucible and then transfer the crucible inside of the SIR 158 to make the extraction happen. Now we can move much more in detail into the total fat determination and see also the analytical challenges and how to set up the total fat determination analysis. We have that for this analysis, we have to fill the crucible before starting the analysis with 25 grams of glass sand at the bottom and then 3 grams of selenite on the top of the glass sand layer. We will have the crucible that appears as I am showing you in this moment. We have the glass layer on the back, on the bottom of the crucible, and then the selenite layer. It's really important to avoid the mixing of these two layers, because we have that both the selenite and the sand helps the further filtration that we will perform on the HU unit. We have that we can offer different crucible size with different pore size to match the particle size of the sample to be extracted. We have that the most used and most common size of crucible to be used is the P1 type, which balances the filtration efficiency and the reproducibility of the results. Now let's look to the indirect extraction and the related analytical challenges, starting with the accuracy and the reproducibility in the crucible preparation. We have that before starting the analysis, for example, if we are with this technique, we can analyze both liquid and solid sample. It's really important, as for the direct extraction, to have an homogeneous sample. So we can homogenize the sample just using a spoon to ensure the uniformity, but also we may need further techniques such as ball milling or cutter or something that can help the operator to have a representative aliquot. Then in each test tube, it's possible to add 2 grams of selenite to support the proper filtration and prevent the clumping of the system. And then after putting the selenite and the sample inside of the test tube, we can put 50 milliliters of for normal hydrochloric acid to make the reaction happen. After the addition, we have to gently shake the test tube in order to mix the sample and the selenite with the hydrochloric acid that we have added inside. It's really important to make sure that any residue remaining on the walls of the test tube, because we have that if some residue remains on the walls of the test tube, the digestion process of this particle does not happen. So it's really important to homogenize all also before also inside of the test tube. And then we can lower the level that we have in the instrument, as I am showing you in this way, and then we can start the hydrolysis process. We have that after the lowering of the test tube inside of the heating block, we can start the process, and we can set the unit up to 117 for 45 minutes to make the hydrolysis process happen. And it's really important in this process to have that all the crucible are linked to the test tube with this aspiration tool. It's really important because this helps the further filtration that we will perform. And after the digestion happened for the 45 minutes at 170, we can filter our sample in each crucible that we have placed into the unit, and then we can perform the further extraction, because we have that the sample after the digestion will pass through this tube inside of the crucible that we have placed here, and then after the washing of the test tube with some hot water, warm water at 50 degrees centigrade, we can remove the crucible that we have placed here and transfer without managing the sample, because we can offer this adapter. We can transfer inside of the extraction cap without touching the sample. So we can move the sample inside of the extraction cap, and then we can move the extraction cap with the crucible that we have placed inside of the HU6. This helps the operator to avoid the losing of some particle of the digested sample and ensure that the reproducibility and the accuracy of the analysis is retained. Now we can see much more in detail some results that we have collected into our laboratories. We have performed the total fat determination in some dairy products, such as cheese and condensed milk. And as you can see, the results shows a low standard deviation with a relative standard deviation that is really low, and told us that the accuracy and reproducibility of the process is retained during the whole process. We have that our result with SIR 158 has been compared with some BIPA standard that we have analyzed, and our result, both for direct extraction and for total fat determination, are in line with the BIPA tolerance range. Now I can leave the word to Mattia to see much more in detail the VELP's solvent extractors.
Thank you, Vittorio, for the interesting presentation. And while we are collecting the last question, let's spend a few words on our instruments. So as you can see on the slide, in our portfolio we have 4 different type of solvent extractors plus our HU6 hydrolysis unit. So 4 different solutions, starting with the semi-automatic extraction. We have our SER 148 in the 3 position model, as well as in the 6 position model. While on the other side, we have our automatic solution, the SER 158 in the 3 position model, as we have here, as well as our 6 position model. So which are the main advantages of our SER 158 compared to the SER 148, as well as most of the model we have in the market? Of course, as you can see here, its compactness, design, and easy access. Indeed, as Vittorio said before, usually we put our SCR 158 inside the fume hood. To have a compact model is very important to save precious space in our lab and under the fume hood, as well as to have a great visibility and easy access to the loading of our extraction caps. Secondly, a smart and intuitive user interface. As you can see here with the control pad, it's very easy to set all the parameters and then press play to start the analysis. And thanks to our titanium condenser, we can have a high recovery rate and reduce water consumption. And also, scalability is an important topic. Indeed, with one single control pad, we can combine up to 4 units, meaning that with just one control pad, we can have a total productivity of up to 24 applications simultaneously. And then, as Vittorio showed before, thanks to the Solvent Express technology, we have a no exposure or a limited exposure to solvent for the operator. Indeed, thanks to this dispenser, we can automatically dispense all the solvent in each column without any exposure to solvents. So let's see some of the questions that we collected. So the first one, Vittorio, is how can I choose the correct type of solvent?
So starting from, thank you for the question. We have that the correct type of solvent can be chosen on the base of the analysis that we have to perform. For example, we have that the majority of the analysis to be run in the food and feed sector, for example, has some official norms that states also the solvent to be used for our extraction. But in general, we can choose the solvent or on the official standard that we have to follow, or also on the chemical compatibility of our matrix with the solvent that we want to use.
Okay, thank you. The second one that we received is when it's necessary to carry out the preliminary hydrolysis process?
Thank you for your question. We have that the preliminary hydrolysis process has to be carried out when we need the determination of the total fat instead of the crude fat.
Okay. Last question for today is how to choose the correct type of gasket.
So thank you for your question. We have that we can offer 3 types of gasket. As I have shown you before, we have the gray one, the white one, and the green one. Both gray and green, so butyl, the gray, and green, the white one, are provided with the instrument and can be used with the majority of the solvents, both with the low chemical resistant and high chemical resistant. But if you need to use a much more aggressive solvent, we suggest to use the Waflon one that ensure an high chemical resistant with also high temperatures.
Okay, thank you very much. We are running out of time, so we will answer to all the questions that we received by email in the next hours. And thank you for the attention. We wait you for the next webinar here from VELP Laboratories. Thank you.
Thank you. Bye.